Hello. Hi, everyone. Welcome to today's DSC Delft event. I'd like for some of you to turn on your webcams if possible. That would be pretty cool because that would be great for the speakers and for you as well to have a bit of a sense of a community. Today's event topic is going to be cybersecurity. We have quite a diverse cast of speakers lined up for you. Everyone from enthusiasts to industry veterans to PhD candidates. We've got it all. And hopefully you guys enjoy it because I definitely do think that this is going to be a great one. So hopefully you're all doing fine today. Feel free to get some tea, relax and enjoy. And we're going to be starting today with Lukas Bernars, who is going to be presenting about the security of IoT devices. I'm going to let him introduce himself. And we should be all good. I will now give you co-hosts and feel free to take it away.
Hello. Let me just set up the screen. Yep, can you see it?
Yep.
Right, so hello, I'm Lukas Baranovas, and today I will be talking about security in the age of IoT. Now, a little bit about myself. I do have a cybersec hobby, so I'm just an enthusiast. I'm not doing this professionally. I am a coder, and I have lots of free time to do this research, and that is mainly where this information stems from. The purpose of this presentation is to give you a little bit of an insight on how hackers approach and exploit these devices in your homes. Also to signify the importance of securing these devices as the market spread is quite big, as you'll see. So what is the IoT? Well, if you build from Wikipedia or Google, you'll get the definition something like this. Again, the Internet of Things refers to a system of interrelated, interconnected, yada, yada, yada. You get the picture. If simplified, I would say that it's basically a network of highly specialized devices that are capable of sending and receiving information between each other. Basically, they create this network, which can really create a diverse and very efficient system, which, for example, boils the coffee when you wake up. If you have a smartwatch, it may signify when you woke up and notify the coffee machine, and so on. Talking about IoT devices, we can see some examples of that, specifically consumer IoT devices. Now, they're all built differently, but they do have the same purpose, which is connect to a network and share information between each other. So such things as a smart thermostat, an IP camera, a smart door lock, or a smart watch would be considered IoT devices specifically built for consumers. Now, we also have the industrial and corporate IoT section, which are responsible for a lot of things such as automation in industrial applications, or translating information from serial servers, sensors, to network-connected devices via industrial control system gateways, as we see in the top left, as well as office routers, which provide internet for the whole office. Now, these are some of the devices, and looking at the IoT market, we can see a year-by-year increase and a forecast of continued increase in the IoT markets, specifically the wireless personal area networks, which really a popular example of that would be Bluetooth, right? So Bluetooth connected devices are taking the market, a big chunk of the market. So IoT is getting more popular, right? It's rapidly growing. Devices are available globally, and basically anyone can walk into a store and buy an IoT device these days. They're also very attractive to users because of their ease of use. Say if I wanted an IP camera, I could buy it and connect it to my network in my home. It would basically be set up and ready to go in about 5 to 15 minutes. And as you will see, this may be a problem security-wise. Right, so we have these devices, right? They're very popular, there's a lot of them. So why don't we break in? Why don't we see what we can break and do with them? Defining some of the most commonly attacked components would be, well, I structured it like this, free components from the hardware side and free components from the software side. A very important component in many of these IoT devices is the Eeprom, which holds the operating system and it's basically the file system of the device. Hackers can use this to pull off data of the device to later use for software exploitation. The second would be serial or Iot. These are debug connections which are very useful during the development of the device, but may provide an entrance point to a hacker if left unlocked. Also, JTAG, which does not really provide a serial console or a direct connection to the device, but it may be very beneficial if you are trying to hack the device. A popular example of this would be the JTAG hack, which was made on the Xbox. Right, so from the software side, we've got the Linux kernel. In these devices do run Linux because some of them just run embedded applications and are connected to the network to do one specific task, for example, sensors, right? But let's talk about IP cameras in this case, and they often run Linux. So we've got the Linux kernel, we've got the OEM services, which are installed and configured by the OEM, and the OEM binaries and scripts. These are often also misconfigured or have security issues, which allow you to perform local privilege escalation. Basically, really easing the job of the security researcher to get into the device. Now, exploring some of these more in depth, I'll again signify that these three most popular issues are hard-coded passwords, which are left in by the actual equipment manufacturers and OEMs, lazy configuration of services. For example, if we go SSH, now we could have, for example, password authentication left on, or the SSH server allowing people to connect via root. Also, user complacency, which is a big problem, really. Many users really don't even know the security issues that they are presenting into the network when they buy IoT devices and connect them. So, right, so these are three major issues, and we'll be exploring two of them, right? So the hard-coded passwords and the lazy configuration in the coming practical examples. So here we've got a standard internet router, which was provided by the popular ISP in Lithuania, Tel, which was now rebranded Telia. Looking at it closer, we've got a web interface, which is pretty standard. And if you go to the actual self-service panel in Telia, through which you control your subscriptions and services and so on, you log in and you have an option to change your Wi-Fi password remotely, right, through the website. You don't even need to connect it through it locally. So how does it do this, right? How does it change the password? Well, here's the schematic. Basically, you connect to your router. You log into the self-service portal. The self-service portal contacts a remote database with specific clients' Wi-Fi routers and passwords, and then that server connects to your router on port 8022 and changes the password with the provided credentials. Now, looking at it closer, the security researcher doing this report noticed that the SSH was improperly configured and the connection was actually not encrypted. You could basically stand in between the server and the router and read every communication that was going on the network. So that's what the researcher did exactly. They pulled off an man-in-the-middle attack with a laptop and extracted the service credentials for that router, which allow more access into the router than the user normally gets. And another issue is that these credentials are shared across all routers that are provided by Tower, which means that basically you can now get root externally on any device. The security implications of this are quite huge, really. A person could connect to your router and monitor your web traffic, manipulate it even, or block certain access to sites. So I think underplaying this would be really not in the best interest of people's security. And when the researcher contacted Telia, they basically shunned him and threatened legal action. So I think that's quite ironic, really. They later released another report on the more modern routers, but this time they did not share confidentially the security details of this issue because of the experience they previously had. So that's an example how companies can really have problems and mess up their relationship with security researchers. Right, another example would be these IP cameras. We've got the OEM, which is Foscam, and two more cameras. They're all based on the same hardware and software code base. So they do share the same vulnerability, which I'm going to be talking about right now. Right, so looking at the connected device market of these specific IP cameras, we can see actually about 1.7 million results worldwide. These specifically can be identified by searching NetWave. Right, and the OEM is Foscam, right? So these cameras can be found worldwide. Not all of these results are cameras, but I would say that at least 500,000 are cameras and at least 300,000 are exploitable by the vulnerability I'm about to present. Right, this is another search engine, which really just finds the similar results. Again, IP cameras that are vulnerable. Here is the standard web interface for such an IP camera. We have a user, we have a password, and we have a login. Now, I would say that the design and the overall design, I think, says a lot about the production quality of these devices, but let's move on. Here's another camera. Again, the OEM is Foscam, but they do run a custom web firmware, which looks different, but functions basically the same. Now, the exploit itself is improperly configured web servers. The proc-k call path in Linux is a file that stores the physical memory of the device. So it should really not be accessed by web servers, and especially HTTP requests on the network. And again, this requires no effort authentication at all. So if we just go to this IP address and this path, we can dump the device's memory, and we can see the ELF header right here. We can see various strings. So we do know that this is the memory. And if thinking logically, the program which, well, the web server, the program which actually checks the credentials you provide to the credentials that are correct, is running in memory, right? So if we dump the memory, theoretically, we should find the user credentials. And that's exactly what we do with this exploit. It was written specifically for the device. Here we can see the MAC address. I've blurred out these details to not reveal any personal information. But we can see after some time, we actually do get a really solid password guess, which later on gives us full access to the device. Here we can see the MAC address is 00B0. So this is one device. And then we have another device without the Wi-Fi configuration, which starts with 000D. So again, the passwords are dumped and the security is defeated. And basically, you can then connect to the camera completely unrestricted and do whatever you want with it. So the implications of the router vulnerability, I'd say, are a lot bigger, since you can really intercept the web traffic more easily. You have a direct connection to an SSH server. But theoretically, in the case of the IP cameras, you could also override their firmware because these specific cameras have a remote capability to update the firmware. So in the case of Mirai, this could be used to create a really big botnet and then use that for DDoS attacks, which I'll talk about later, or just simply infiltrate the network. Right, so security implications of these devices and why should they really be taken seriously? A lot of these cameras are indoors. A lot of these cameras are targeted at living rooms, at bedrooms, and there were reports of hackers accessing the Ring cameras remotely, specifically. And this is really an invasion of privacy and security. So I think really no one would like to be spied on in their home. About the Mirai botnet, it was actually a botnet of all of these, well, not all, a big number really of IoT devices, which was then used to carry out an attack in 2016 on DNS servers, which rendered quite a lot of major websites in America unreachable, such as Spotify, PayPal, Amazon, and Netflix. So this is an example of how these IoT devices can be clustered and used for the greater bad, so I would say. And another example is the Ukrainian power grid. Even though the initial entry point into the network was not used, well, did not use IoT devices, when they got into the network, they actually overrode the firmware of some of the controllers that controlled the substations, right? So operators could remotely switch on and off the substation units, so they could provide power or turn it off. So they overrode the firmware, so that would no longer be possible, and the operators would have to manually turn on and off the substations, right? And the firmware override was completed on such devices as these PLCs that I talked about earlier, and specifically ICS gateways, which were vulnerable. Right, so closing thoughts. I know this was a quick presentation. I do believe that the security of these devices is very poor and should be looked at more seriously. Companies and OEMs have about zero accountability when it comes to securing their own devices and clients, in the case of Telia, as I talked about earlier. And user education is completely insufficient, and we should really hold more talks, hold more presentations, and get the word out there that these devices have problems and are vulnerable. All right, that's the end of the talk. Thank you for your time, and I would like to take any questions if anyone has them.
All right, nice. Applause. If everyone can unmute, just give it a bit of a clap. Give Lukas a clap in this virtual space. Yeah, it's a bit depressing, but that's the best we can do. All right, questions. Feel free to just unmute and ask if you have anything. You should be able to. I myself have a question. What would a person that would, or that could be interested in doing these things, or for example, wanting to get into, finding exploits, how could they start? What's like a good base on GitHub perhaps, or?
Yeah, so starting, getting into these exploits, I think really you should focus on one of the main branches of computer science, which are required to carry out these exploits. So one of the main branches I would say would be understanding assembly, or at least more in depth how the computer works, because that's really a major part of disassembling these devices and exploiting them. Sometimes you can find firmware updates, which are actually the full firmware files, basically the whole operating system, which you can download from the internet right away. But oftentimes it requires more in-depth knowledge and exploitation of the hardware. So I really would say start with looking at the computer more in depth, especially different architectures, and learn about assembly language, how programs are actually compiled into machine code. You don't actually have to learn machine code. Assembly is sufficient, but yeah, I'd say that's a good starting point for this.
Nice, thanks.
So maybe I have a question.
Yep.
So on the previous slide, you showed 50% education and then 0 and 0. So where does the rest of the 50% go? In other words, from an offensive security perspective, what should the defensive people be doing differently?
Right. So from the offensive security perspective, really, I think, again, it comes down to accountability for your own product to the company. I think really companies should invest a lot more into cybersecurity and not overlook these issues during development, because currently, as in the case of FOSCAM, there's basically zero security. I mean, they're patching up a bit right now, but yeah, even having a basic pen test, the device would be a lot better than what we have right now. So I would say just do at least the bare minimum, like not nothing. Right. Do you have any more questions?
Yeah, I have a question. First of all, Lukas, thanks for the talk. My question would be, how do I make sure that no one spies on me through my IP cam? What are the 3 steps, let's say?
Right. It really depends on what IP camera you have. I would say even before buying the IP camera, you should do some research into the vulnerabilities and the company's reputation of which you're buying from. And if they check out, or if you already bought the camera, I would still suggest looking up the model number and searching for potential vulnerabilities and perhaps some steps you can take to ensure that they are mitigated. For example, FOSCAM actually is releasing security advisories for the clients currently. So if you have a FOSCAM device, you can go to the company's website and learn steps you can take to protect yourself.
All right, thanks.
I also have a question in regards to the development side of the topic. Is there any set of best practices that the development teams can apply or look after in order to prevent this kind of vulnerabilities in the products?
Right. To be honest, I really don't want to go out of my depth here. So I will say that I do not have experience specifically with DevSecOps. I haven't been involved in production of these products, so I can't really suggest concrete examples. But I would say that hiring someone experienced and even keeping that in mind, that security issues can arise, and taking steps to mitigate that, such as hiring a consultant or professional, would be a great step in the right direction.
Thanks.
Yep. Any more questions? Anyone?
All right.
Yep.
Yeah, I think we're good. Lukas, thank you very much for your talk. It was great. I'll share my break screen. By the way, Lukas, if you have any plugs, any GitHub projects, any cool links you'd like, drop them in the chat so that anyone can reach them. And yeah, we'll take a quick break. It's going to be about 5 minutes. We're not dragging this on for too long. Yep, we'll get back to you soon. Go get some hot cocoa or to the toilet or something. All right, see you soon. Okay, welcome back, everyone. Let's see if I'm visible. Let's see, boom. Hey, all right, our second presentation, if everyone's back, I hope everyone is, will be presented by Azqa and Nadeem, who's going to be teaching us a bit about machine learning and cybersecurity. Now, this talk was specifically recorded for this event by Azqa in advance because of ongoing internet issues that she's been having. but she is present in the call right here. You can even see her. So she'll be present to answer any questions that you may have after the presentation's over. So we're just doing this to ensure that everything goes smoothly, because chances are some internet interruptions will happen in the middle of the presentation. So I'll now spool up the video, and we can enjoy it together. Let's see here. There we go. There we go. Okay, let's go.
Hi, everyone. Good morning, good afternoon, good evening, depending on wherever you are. So today I want to give you a very quick crash course on my area of research, which is machine learning for defensive cybersecurity. But first, let me tell you a little bit about who I am. So I'm originally from Pakistan. I did my bachelor's from Pakistan, and then I came to the Netherlands to pursue my master's, which is also where I picked up an interest in cybersecurity, which I decided to continue into a PhD. Currently, I'm a third-year PhD candidate, and my area of research is actually a very narrow area of machine learning, which is sequential machine learning, where we develop models and pipelines that can find patterns in sequential data. And as some of you would know, I'm also a lecturer, so my responsibility is also to introduce security in existing bachelor courses at EEMCS, because we don't have a dedicated security course. And other than that, in my free time, I am a landscape photographer. So I really, really enjoy traveling and capturing landscape. And as you can imagine, during these Corona times, during the past year, has been quite boring. So let me start by talking about the current state of security that we have. I want to show you a few clippings of recent news articles, and we'll see, what's going on. So the first example is about this SolarWinds scandal, which has been blowing up in the media recently quite a lot. And this is that we recently discovered that attackers injected malicious code in the source code of Microsoft, which means that a lot of tools that Microsoft develops, which are used by practically almost everyone in the world, ranging from a layman to intelligence agencies and government institutes, had that backdoored version of Microsoft products, right? And this is a huge thing, because the attackers have been spying on us, surveilling us for quite a long time. And when I say us, this was primarily meant for the US, but this tells you how advanced the attackers are. And the second example is actually very interesting. Apparently, there's been a hacking campaign going on against security researchers, where what the attackers do is that so it's very common that, for example, if I have a piece of malware that I want somebody to analyze, I'll just contact one of the security researchers and I'll say, I have this piece of malware, can you analyze it? And so what these attackers did is that they contact the security researchers for analyzing malware, but this time they give them, a backdoored version of Eclipse or Microsoft Visual Studio, that when the security researchers download, there's a backdoor on their computer, so attackers can now, penetrate their system. And I recently also saw a tweet from a famous security researcher who had the same thing happen to them. But luckily, they ran the Microsoft Visual Studio in their VirtualBox, so not much damage was done, but they were willing to pay a lot of money to find the person who managed to do that. So it tells you, the attackers are doing kind of a lot of things, and they are very, very well equipped. And one of the key technologies that attackers use for their tasks is malware or malicious software. And this plot is just one of the many, many plots and statistics that we have seen over the years. And we see that in the last 10 years, malware has grown exponentially. Right now, we are at the point where we see enough malware that it's not practical to analyze all this malware manually anymore. Malware analysts cannot do that. There's just simply not enough hours in the day to do that. And so we as defensive security people, we really, really need some help. And that is where machine learning can actually help us. So what machine learning does is that it tries to learn patterns from input data. So the idea is that you have raw data where you have, lots of different types of data points, and you want, a magical box, which is called machine learning model, that will distinguish or separate out the different patterns that can be found in the data, such that later on when we see new data points, those patterns, they hold up and the model is able to recognize those again. So the first step to doing that is, it's not just a magic box. You have to, do program it just a little bit. And that has to do with feature engineering. So the idea is that we extract features that are characterizing information about the input data. And that is what is given to the model as input to learn from the raw data. And so in this case, if we want to separate out all the strawberries and the apples, we can say that, our features could be maybe the shape of the object and perhaps the location of the seeds. And so with those two features, we're going to transform the input data into that feature representation, and we will give it to the model, and the model will learn the patterns and outcomes, the output. Right. And there are also different kinds of machine learning. So there's supervised learning, unsupervised learning, semi-supervised learning, but the idea remains the same. Machine learning model is essentially a bunch of mathematical equations that are trying to optimize an objective function. In this case, our objective was to be able to separate out all the strawberries and the apples, and that is what we can also evaluate it on. So in case of supervised learning, we actually have labels that can, so these are labels of the raw input data, and we know exactly what each input data was. So we can see whether it was assigned to the right class, and we can have, maybe accuracy measure or F1 measure and so on. But in case of unsupervised learning, we don't have the labels. So in that sense, I guess the most we can do is we can, separate out the data based on maybe behavioral differences or based on textural differences, depending on what the features are, of course. And so we get these groups made from the data, and these are separate because the features for these two groups are quite different. And so a human analyst will have to come into the picture and say, what are the items in this particular group? Well, they all seem like strawberries to me. So we'll just label this group as strawberries and this group as apples, right? So there is some human element involved when it comes to unsupervised learning. But anyway, the point is that we can use machine learning to find these patterns. And well, in the case of security, the input data is a lot more complicated than simple pictures. And the idea is that we will have maybe behavior user actions, or we will have a piece of code, and we'll have to figure out whether it's malicious or not. And so we know that the threat landscape is actually very wide, and there is a lot that we as defenders have to do in order to protect all of our bases, right? So there's a lot of opportunity for machine learning. I'm not going to read out this list, but basically the idea is that any security problem you can think of, you can probably try to apply machine learning on it. Whether you'll be successful or not is a question, right? But the other thing is that machine learning is not just a technology that defenders use, it's also a technology that attackers can use to build even more powerful attacks. But the offensive security part, that's not what I'm going to cover today. I will give you a few concrete examples of the defensive security and where we use machine learning. So the first one is that there was recently a work that tried to detect and patch buggy code, right? So it's not just one of these works. There's also some other papers that try to do something similar. And the idea is that when we write a piece of code, there could be vulnerabilities in there, there could be bugs in there. So we train a machine learning model that can recognize what part of the code has the bug in it. And so it's not only able to detect the bug, but it's also able to produce a version of the code that is the corrected and fixed version, which is super cool. Then we have anomaly detection, which is a great example of unsupervised learning, where we have a lot of data points, but we don't have the labels for them. So we don't know which are malicious and which are benign. And the idea of anomaly detection is that we try to learn the normal behavior of the system. So the idea is that if you are running, for example, a water treatment plant, then we will try to learn how the normal, under normal circumstances, how do the sensors behave? And then if there's any deviation from the normal behavior, that is an anomaly. So we can raise an alarm, and an analyst would then have to look at what the anomaly is. And the problem is that not all anomalies are malicious, so you have to keep that into account as well. Then in terms of malware detection, of course, one example is just that, we want to learn a model that given an input piece of code, they're able to tell whether it's malware or not, but there's actually a lot lots of other applications in malware detection field. One of them is the fact that you can predict impending exposure. So the idea is that there's a machine learning model in your browser that's analyzing your behavior, learning from your browsing behavior, and it can tell you in certain cases up to maybe 30 seconds in advance that you're about to land onto a malicious page. So it tells you, it warns you that whatever page you're going on to next is probably malicious, so don't do that. So this is an example of proactive security measures. Okay, you can detect malware, but the other application, the other side of that is analysis and being able to understand malware. And for that, we can do capability assessment. So the idea is that we learn a model that, well, of course, it is able to detect that it's malware, but it also discovers all the behaviors that this malware is doing. And so it's able to construct a behavioral profile. Right, and this profile will tell about all the capabilities that this malware was doing, and so it's a lot more insightful than just saying, well, I detect a sample of Zeus versus, well, I just detected this piece of malware and it's doing XYZ different behaviors, right? So it's a lot more insightful, and that's why this area is very important. Then we have the area of adversarial machine learning, which is a very popular field right now. And the idea here is that because we know that malware will try to evade detection, why not learn classifiers that are robust, that already anticipate that they will try to evade detection, so they're able to detect them as well. So the idea is that under normal circumstances, if you receive a goodware, obviously it will be considered as goodware. And if it's a malware, then the classifier will say block it because it's malware, right? But we know that attackers will often try to modify their malware such that it looks malicious, it looks benign. And so we have seen that machine learning classifiers, especially deep learning, is very susceptible to these kind of attacks. And the classifier will very easily be fooled and will say, it's benign, so let it go, right? So those are the kind of evasive malware samples. So what adversarial machine learning tries to do is that the model will try to craft adversarial malware examples that it hasn't seen before, right? So these are probably all the changes that maybe attackers can make, and it tries to incorporate them back into the training process so that the classifier has already perceived, anticipated the kind of changes that attackers can do, so that when attackers try to do those changes, the classifier is already prepared and it's able to detect them. So this is actually a very, very important area of research that tries to learn more robust models. And finally, we also have author attribution, which I think is a really cool and fascinating field, which is given a piece of malware, we try to figure out who wrote it, right? So we try to attribute a malware with a human who actually wrote it. And the idea is that we learn a model that tries to extract stylistic features from the piece of malware. So for example, how the code was written, or whether there are any idioms that are used very frequently, things like that. And it tries to map them to profiles of software developers maybe, or people who have written code before. And if it finds a match, then it says, okay, it's very likely that this malware was written by person X. But as you can imagine, the problem is, where are you going to find these profiles to compare against, right? Attackers are not going to give you their code and say, match with my code. So this is that's why this field is very slowly growing, but it is very important. So what's happening in the industry is also a very interesting picture, because we do see that there's a huge gap between the problems that academia thinks are interesting. So all the examples that I showed you were from academia, right? These are research papers. And also what the industry is doing. So I'm talking about security companies, maybe antivirus vendors, things like that. And so I'm not saying that machine learning is not applied in industry, but the adaptation is actually significantly slow. And that has to do with the fact that we're not able to provide security guarantees, privacy guarantees to clients about machine learning. So in the case of adversarial examples, we already saw that it's very easy to fool these classifiers. So industry, because they security companies, they have data of their clients and they are liable at the end of the day. They are very, very cautious about what kind of systems they use and what kind of systems they implement. So in that sense, it's machine learning is not very readily applied in industry, but it is slowly changing as we are moving towards more robust kind of models. And so this brings me to the next point, which is machine learning is actually not a silver bullet, right? It's not going to solve all your security problems. And the reason why I think that it's very important to mention it, because in the media, it seems like whenever you have machine learning or AI, it seems like it's a savior and it's going to solve everything. But actually, that's not the case. And the fact that you're applying machine learning to the field of security means that this is interdisciplinary work, and you really have to understand the unique challenges of security field to have the right assumptions that these models can be applied and they work, right? So this is very important. And then with deep learning, it seems that there's an interest to automate everything, automate feature extraction, automate feature selection, automate learning the model and everything. But the problem is that you're, inevitably, you're turning it into a black box. You're taking control away from the analyst. So we don't have any control anymore of how or what is being learned. And we're not even in the position to be able to debug these models. And if that happens, then we have a huge problem on our hands. We have ethical responsibilities that the models that we are learning don't have any biases in there and they don't discriminate. So then this becomes a huge, big mess. So all in all, the point is that black box models are not good when it comes to being able to understand what is going on and to be able to debug the models. And so now I want to give you what I consider to be the top 4 problems or challenges that you have to be aware about when you are trying to apply machine learning to the security field. And the first one is the huge class imbalance problem. So we know that in the real world, there's significantly more benign software than there is malicious software, right? And so the fact that we have this huge class imbalance means that if we are learning models with unrealistic class distribution, it means that these models will not hold up in the real world. So if you are, there were works that are trying to learn models with 50, equal class distribution, meaning 50% malicious and 50% benign class distribution, but that's actually not how it works in the real world. So these models can give you 99.9% accuracy on your test data, but when they are deployed in the real world, they don't perform that well. And then the other problem is that if you have biases in your data, then your model will also be biased, and it will then, deployed in the real world, it will create some problems. So the solution to this problem is rather straightforward. You can go out, have a survey of in the wild, what is the class distribution, and then use that class distribution. So have the correct assumptions. There's also imbalance aware algorithms. The second point is that the landscape is very adversarial. We know that, and it brings along with it some unique challenges. So we already know that attackers will try to hide, they will try to evade detection. This means that the attackers will try to craft malware that evolves very, very quickly. And those changes are so big that the machine learning model will not be able to detect them. So just because you're using machine learning doesn't mean that you can detect all changes, right? So that's something that is really important to understand. So this is the concept of the out of distribution samples. So the idea is that if you're learning a model on the green and the yellow sort of distribution, then we will be able to detect samples that come from these distributions. But if there's a change so big that the malware comes from maybe the red distribution, then the machine learning model will not be able to classify it correctly. So it's important to know what kind of claims you can make and what the claims mean when it comes to machine learning classifications. And so, a relatively simple solution would be that if you learn from representative data set, then the problem is solved, right? You have seen all the data, and so you know everything that the attackers can do, and you can detect them. But actually, that's not how it works. I mean, getting realistic data set in the real world is, especially in security, is a really, really difficult problem. And so, focusing on the data set, yes, it's a good thing, but you should also try to deploy other solutions. And one of them can be that you try to go towards a continual learning approach, meaning that when your machine learning classifier starts to degrade in performance, you trigger a relearning pattern. So the model learns from newer data, right? So as the threat landscape is evolving, your model will be evolving with it. Then the next point is knowing what to evaluate. It seems easy, but actually, this is it's a difficult problem. And the thing that I want you to remember is that just because these are high performance metrics, like just because you have 99% accuracy, does not mean that you have better security. I want to give you an example of that here. So let's suppose that you have 99% benign data samples and 1% of them is malicious. Right? When you're going to learn a classifier on this huge imbalance data, you will see that for the new data sets, you'll get an accuracy of 99%, right? But just because it's so close to 100% doesn't mean it's a good thing, because the task that you started with was that you wanted to detect 1% of those malicious items, but you're still not able to do that, right? So that doesn't mean that your security is improved. It just means, okay, the number is close to 100, but that doesn't mean anything. And the other thing is that these performance metrics are actually impacted by a lot of different things. They are impacted with the kind of data set you have. They are impacted by the parameters that you use, and they're also impacted by the underlying assumptions you have. And so any of these things can fail when you deploy these models to the real world. So don't be fooled by very high accuracy numbers. If 99% accuracy of detecting malware meant that you can actually detect all malware, we wouldn't have a malware problem today. So it's a very important problem to remember. And so this is why I think that it's important that instead of obsessing over 99.9% accuracy, we should actually try to have better insights from the model. We should, even if your accuracy goes down, if you're better able to understand the input data, the kind of patterns that are there, then you can incorporate that in the model and you can improve your model. But if you only have 99% accuracy, okay, this is a high number, but it doesn't say anything about how the model will generalize and whether it will hold up in the real world. And finally, knowing the extent to which machine learning can be used is also a very, very important thing. So I recently read a quote, I don't know by who, but the quote said that the real indication that you understand a technology is knowing when not to use it. And I think that applies to machine learning very well, because there is this work that tries to implement machine learning models for everything. They try to automate every single thing. But actually what we need to remember is that there are certain things that machine learning models can do really, really well. Like they can find patterns significantly faster than humans, but then these models are sometimes also really, really stupid. And we see that in security, it's actually very easy to fool machine learning classifiers. So that brings me to the next point, which is, I mean, we're really not at the point where we can replace human intelligence. Okay, so instead of trying to achieve 100% automation and trying to automate everything, I think that we should try to incorporate the human in the loop, and we should try to learn models that are more explainable. So even if we don't get a very high accuracy, at least we're able to understand why a certain classification decision was made, what are the patterns that the model is learning, and we're able to debug that. So that's really important. And so we should, we should go towards human in the loop machine learning pipelines, which is that we try to assist humans rather than getting rid of the loop, right? And so once we include the human in the loop, we use the human intelligence and we understand what is going wrong if something is going wrong, and we're able to correct those. Right. So to conclude, I want to give you the 3 takeaways from my talk today. So I hope that you would remember them, and if you, especially if you want to apply machine learning to security and if you want to go towards that field. And the first one is that machine learning is, without a doubt, very, very powerful technology. It frees up humans to do a lot more complex tasks, while the machine learning models do, the predictable things. They crunch huge data sets and extract insights from them, while humans try to make sense out of them and try to understand them. So it's a very defensive, it's a very powerful technology for defensive security, but you should understand that you cannot just blindly apply it. You really have to understand the underlying assumptions, the underlying unique problems that the security world brings with it, and then you can apply machine learning to those problems. And of course, that goes without saying that not all problems in security can be automated. The second one is that machine learning is a technology that is not only being used by defensive security researchers like me, but they're also used by attackers to do even more powerful attacks. So instead of relying on better performance and thinking that better performance means better performance metrics means improved security, I think that we should focus on better understanding of our input data, of our models, and making sure that our model is actually learning the right thing. And if there's something wrong, or we know that models can be easily fooled, so we are better able to make them robust. We're better able to equip them with detecting evasive attempts in the future. And finally, machine learning is not a silver bullet. It's not going to solve security, really. It is not. Okay, so we have a really long way to go, and so we should try to help analysts rather than throwing them out of the loop, trying to automate everything. We should really try to utilize the human intelligence and incorporate that with machine intelligence, machine learning, and then we will be able to detect a lot of attacks and have more advanced security. So this brings me to the end of my talk. Thank you for your attention. If you have any more questions, I can take them. And my contact information is on the slide in case you want to get in touch.
Wonderful. Thank you very much. Great presentation. Let's give Azqa a round of applause. Unmute. Yeah, look, it almost works. Nice. All right, let's do questions.
I have a question. What would you say is a good balance between the use of AI and the use of SOC analysts? Because the company I work for personally struggles with this on a daily basis. We're trying to automate stuff, but then again, we can't rely on it. And if we don't rely enough on it, our SOC analysts get absolutely overwhelmed. They can't do anything anymore. So what would you say is a good balance between there?
So it's a difficult task to just put a number on it, because the problem is that right now with machine learning algorithms, we cannot give a concrete number on how well it performs, because it's really difficult to measure security. I mean, if you deploy a solution, are you having improved security because of the countermeasure that you put, or because attackers are not attacking anymore? Right. So, so the absence of attacks is not a good measure to measure security. So that's the number one issue. And I know that the SOC analysts and the fact that they have a huge overload of the work that they have to do, this is why SOC analysts usually get burnt out very quickly. And it's not a sustainable way of life for anyone, I think. But yeah, I mean, I would love to say that machine learning can really help them, take half of their workload off. But actually, the problem is that right now we're not at the level where we understand machine learning well enough to be able to replace human intelligence. And things that are really easy for human analysts, like you look at a picture and you know exactly that it's similar to another picture or what the context means. That's something the machine learning struggles with. Yeah. And the solution that we're going towards now, there are more deep learning approaches where the model just becomes a black box. So right now, there's an emphasis on explainable machine learning, where deep learning models we now have experimental techniques in order to explain what a machine learning model is doing. Maybe we should focus more on that. But yeah, I mean, the problem that you talk about, it's hands down, it's there, but there's no quick solution to that.
Yeah, I mean, that's what we're facing every day, so it's very understandable.
Yeah, but I wouldn't recommend the SOC way of life for anyone.
No, definitely not.
That
No.
sucks, right?
Go red team. Go red team, everyone.
Can I ask a question, Azqa?
Yes.
First of all, thank you for your presentation. It was really great. And I think also you mentioned that data collection for this field is very difficult. And I think you mentioned also that the trend is working towards the deep learning algorithms, and deep learning algorithms are very easily can be overfitted. I'm trying to understand how you are doing the data collection, because it's very difficult. I can't think of how you are doing that. And then the other thing is how you do the data augmentation, because it can be introduce more noises and bias into your model.
Okay, so for the first question, there are actually a couple of ways in which you can collect data for experiments. One thing is that you can go in collaboration with an industry partner who, like SOC analysts, right? They have the real world data. So you use that data and you learn the models and you see whether it works. That is really the ideal way to go about it, because that really, it's the best combination of academia and industry. The issue is that these security companies are often dealing with sensitive data of their clients. And so there's a lot of legal, red tape around that. So it's really difficult to get access to that data. The other alternative people have is that they set up local labs, and there they collect this data. But of course, it's lab generated data. If, for example, it's malware, then you can get samples from the internet, you can execute them. But of course, because you're executing them in a sandbox, it's possible that they're not really generating the actual behavior that they would generate if they were on a victim machine. So this is why, like, it's not just the problem of data not being available, it's just the problem of how trustworthy the data is, how generalizable it is to the real world. And then as academia, how easy it is to get your hands on it when maybe you're doing a PhD and you only have 4 years. And the clearances and the red tape takes 1 year, right? For the second part of your question, I didn't quite understand what you mean by augmenting the data.
Okay, the data adversarial, you mentioned that, okay, you are generating some sample data for to train your model with. Then that's the question, that how you can ensure that the data that you are generating is generalizing and it's making a sample of the real world situation. I think it's also related to the first one.
Yeah, not exactly. So adversarial machine learning, what it does is that it looks at it from a completely mathematical point of view. It considers the threat landscape to be, it considers to be a search problem, that you have a very complicated hyperspace where any malware sample that you can think of is a point in that hyperspace. And so the model that let's say the decision boundary is essentially that hyperspace, and we're trying to optimize it so that on one side you have benign stuff and on the other side you have malicious stuff. So what adversarial machine learning does is that based on the knowledge of that decision boundary that you have learned, we're going to try to make small perturbations in the input samples that we have, such that the malware classifier will misclassify the example. So you have found a valid malware example where you change maybe 1% of the data and the malware classifier is not able to detect it anymore. So you're going to give it back to the learning algorithm. So in this way, you do it repeatedly enough, and obviously you have to make these perturbations smartly. You can't just randomly do them, because in the case of malware, you can't just randomly make changes, because you have to, as an attacker, you have to make sure that the malicious functionality of the malware is preserved. So that's another area of offensive security, where you have to craft malware examples where the changes are big enough that they cause a misclassification, but still preserving the malicious functionality.
Yeah, exactly. Okay, thank you.
You're welcome. There's a question in the chat. So do you have any hope that eventually software will be able to detect unseen malware, or do you think that the approach is generally flawed and we should rely on approaching like sandboxing by design? Yeah, so I think the answer to that is what I just explained about adversarial machine learning. I think it's a good way to go. Of course, we really have to figure out the best way to learn robust malware classifiers. So if incorporating the offensive security world helps you learn more robust models, that would be a great approach. It's just that at this point, the literature is going more towards deep learning because it's just so much easier to fool deep learning models. But for example, our group is working also on robust decision trees. So classifiers that are not deep learning, you can basically provide security guarantees how robust they are. So there is a trend towards that, and maybe hopefully in 10 years or so we'll be able to get there.
Thank you.
Any more questions?
I have a quick question. Is there any ready software solutions for the machine learning based I don't know protection anything for either consumers or enterprise people? Because you said that it's not very adapted yet, but I'm wondering if there's anything.
So this is a very good question because it depends on how invasive the machine learning is. For example, the antiviruses or anti-malwares that you have probably on your computer, they do some level of machine learning, but it's not very advanced. We are currently in talks with some security companies that do build these anti-malware, antivirus systems, and they say that they are mostly interested in classifiers that they can understand. That means that robust random forests is the maximum extent to which they're willing to go. Anything deep learning or anything where you have ensembles and you have more complicated classifiers, they're not going to go there because if they cannot explain it, they're not going to use it. So that's the number one problem why we don't have a lot of consumer tools that have this incorporated machine learning. The second issue is that, what was I going to say? I just forgot. Yeah, so the problem is also how you're going to train the model, and of course, whether if you incorporate that trained model in the consumer product, it has to repeatedly learn, and that's a lot of overhead, I guess. So the privacy is also a concern there. So there are like homomorphic encryption people who are trying to learn models that learn in a privacy preserving way. So there's a lot of experimental stuff going on there, but it's not very, how to say, performance optimized. So it's not really realistic to deploy it to actual consumers. And yeah, so the third thing I want to say is that right now, this is actually a very good field if you want to start an entrepreneurial business or a venture. If you can just say you're like a data scientist or a machine learning person and you have a little understanding of security landscape, then there are people who are doing data analytics for big companies. They give them their data and then they apply machine learning models and they give them the insight. So, it's not consumer tools. It's like small entities are forming that have understanding of both of the fields and that are trying to offer their services to these big companies who can potentially benefit from machine learning.
Yep, thank you very much. Anyone else? Okay, nice. Thank you very much again, Azqa. Great presentation. Honor to have you on.
You're welcome.
We're going to take one more 5-minute break before the final presentation. So feel free to cozy up a bit more, I guess. And yeah, we'll be back in 5 minutes, basically. Yep, see ya. All right, welcome back, everyone. Turn on some cameras if you'd like, not forcing anyone to do it, of course, but there was a question in chat regarding the previous talk as well. So if you guys are interested, go have a look. And yeah, let's continue. Now we're going to move on to Jafar's presentation. and he'll be talking about security within DevOps, which is a super interesting topic. So take it away. Good luck.
Okay. Do you see my screen?
Yep.
Okay. Hello and good evening, everyone. I hope that you enjoyed the talk so far. I did myself. My name is Jafar Shayan, and I'm going to talk about Devsecops. So the agenda of my presentation will be introduction of myself, and then I will go through the what's the Devsecops and why Devsecops. Then some implementations of the Devsecops guides, and at the end it will be the questions. So first of all, who am I? My name is Jafar Shayan, and I'm a continuous learner and continuous improver. I hope that I can be called as that. And I'm a software engineer at OGD since 2018. I have more than 18 years of experience in the IT field, and still I love it. I have been working as software engineer, team lead, manager, and so on. I have done my master in IT management. My thesis title was Risk Management Framework for Cloud Computing Environment, and it was a fun project that I have done it in 2012. My PhD was in computer science. It was related to the ML, but in computer vision. It was different from the Azqa's field. So what is the DevSecOps? I thought that it's cool to look into it from deciphering perspective. So in deciphering approach, we have the cipher text, and then we have a key that we can decipher the text. So I wanted to apply it to the DevSecOps. So we have the DevSecOps as a cipher text. And then I was thinking that maybe the key can be shortening and shuffling. Then we have DevOps and security. So let's verify whether it's true or not. We can see that. So first of all, DevOps. And that's really interesting because I have realized that we don't have the unique definition and perceptions of DevOps between different people. I have been asked to talk about DevOps back in Malaysia and here in Netherlands, and then I realized that we don't have, we are not in the same page when we are talking about DevOps. And as a fun fact, I think you can look into the job descriptions of the DevOps engineers or experts, and then you can figure out that they are asking for the DevOps experts, but what they are looking for is the system engineer, or they are asking for the network admin or something like that. But what's a good definition for DevOps? I found this definition from the Donovan Brown interesting, and I like it. By the way, Donovan Brown is a cool guy. I agree with him in a lot of areas, and he has done a lot of great job, incredible job in the Microsoft from transforming from the waterfall way of working Microsoft to DevOps way of working. His definition is saying that DevOps is union of the people, process, and products to enable continuous delivery of the value to the end user. I like to just change products to technology, so it's combination of the people, process, and technology. But then what's the definition of the security? So I just got this definition from the ISO 27000, but the version of 2009. So you can see that it is saying about preserving of the confidentiality, integrity, and availability, plus some other properties that they borrowed from other standards. But one thing that is missing there is the context. That definition has no context, and it's vague, at least for me. And I was thinking that, okay, although that these principles of the information security are the basics, the cores, and everyone knows, but maybe it is good to just look back these things and go back to the basics, because in my experience, I have talked to some information security officers, even some CISO, that they forgot about these principles or they overlooked these principles. And I think that's good to just review them again. So let's start with the first one, which I think it's one of the most important facts. And it says that no such a thing as absolute security. I think Azqa also touched it with, she said that there is no silver bullet. And I can highlight that. And if someone says that, okay, we are trying, we make the unbreakable system, they don't have enough experience, because in this field we can't guarantee 100%. And one sample that it's very well known is in 2003 there was a collection of the Whitworth Gallery in UK that they thought that, okay, they had the best security ever and it's unbreakable, and they had some masterpiece of the Van Gogh, Picasso, and so on, but that some people broke into and they stole those paintings. But they had a sense of humor. They left those paintings in the public restroom just a few 100 meters away with a note saying that this was the intention was not to steal, but only to highlight the woeful security. So be aware of this. And then the next one that what I wanted to highlight is in the field of security, it means the risk management. So it's all about the finding the balance. And then that's something that we are doing every day in our life. It's like, and it's very obvious for us, but when it comes to the information security, it becomes a little bit difficult because we can't make those decisions tangible. For example, in your daily life, if you have something asset that it costs 200 euros, you won't buy a 500 euro safe to put that asset inside, because it doesn't make sense. But in real life, how you can make the information information assets tangible, how much it costs and how much you should spend to make it safe, and it's dynamic. So of course, it's also about the confidentiality and integrity and availability, which is called as CIA8, right? And then the other thing that I like to highlight here is it's also related to the first principle and the risk management. It's layered security, that sometimes it's also referred to as onion approach. It has this assumption that you can't guarantee the 100% security. So you should have different layers, that if the layer 1 is compromised, then you have the second layer to just protect you. And if the layer 2 is compromised, then you have layer 3. But how many layers do you want to have? It goes back to the risk management, that you should analyze and find the trade-off, that how much that it is important for you to keep it safe, so you can spend more money and effort on keeping it secure. The other thing is, okay, it's all, and this principle highlights the importance of the people in the picture, because the root cause of the social engineering attacks are people, and then it is important to highlight it. There are many research that shows that people can be fooled easily. There, for example, organizers of Information Security Europe, they sent some people to the Waterloo stations of the Waterloo station in the UK, and they asked the people that, hey, can you give me your office computer password in return of a pen? And guess what? 3/4 of those respondents, they did that, and additional 15% more, they did it with some gentle probe. So you can't, and I think the importance of the people also was highlighted by Azqa, that humans should be in the loop and cannot be, yeah, so that's something else, but I can touch it back later on. So it's also highlighting the importance of verification and validation in this field, but yeah, security through obscurity, hiding the details of the security mechanism is not sufficient to secure the system. And it used to be the way that people are trying to secure their systems, but now they know that it's not the good way to do it, because it gives you a false sense of security, which is really dangerous. You should be, you should have a realistic view of this your system to know that, okay, so if you don't have the real picture, then when you are doing the risk management, you won't be able to do it correctly. And the other thing is against the defense in depth, because if you rely on this obscurity, and if it fails, if it collapses, then your system will be compromised. So this principle is repeating the first principle and then defense in depth, because it says that, okay, your system will be compromised at some point, so you should have some detection mechanism and response mechanism. In the realistic response plans for COVID-19, also we should have these three mechanisms that we know that, okay, we can't prevent that, so we should have some detection mechanism, and then we should be able to respond to that. So yeah, complexity is the enemy. I hate complexity, and I think everyone else as well. But why it is dangerous for us? Because if you don't know your system well, then you won't be able to secure your system. And there is something which is called snowballing complexity, which exponentially grows your complexity, and it becomes more difficult for you to secure your system. There is a saying that says, urging for sophisticated solutions is inevitable. Always simplicity helps. Often embarrassingly simple solutions are solving the most challenging problem. And this is from myself. So this one, it is referred to as FOD tactic that for quite some time the CISO were using this, and I think they overused this card, and that's why it's not working anymore. So you can't just they were playing this card to secure their budget by scaring the board, but now it's not the way to work. And this principle is highlighting the people, process, and technology. It says that we should have these three pillars in our picture to make our environment safe. And then, disclosure of the vulnerability is good. It's also related to the principle 6 that says that security through obscurity is not the answer. And in the real life, we know that, okay, if you know the vulnerability, just tell the users that, hey, this is the vulnerability, so that they can take extra measures to keep themselves. And there are some argue about that. They said that, okay, if we disclose it, then the attackers will exploit that. But anyway, they will exploit it, and they are much faster in communication rather compared to us. So that's something that we should practice. But why Devsecops is important? Because we know that modern life relies on information systems, and we know that everything is connected, and information system is used everywhere. And we have our critical infrastructure also relying on information system, and the security of these systems are really important. So well, it's really important. And I like to look into it from the risk management perspective and see that, okay, which options we have. So the likelihood of the threats for us in this system is almost certain. We know that, okay, we have the threats. I think every day you are hearing that exploits and then some incidents that's happening. But what will be the impact for us if those compromises happens? That's severe. So imagine that if the nuclear plants is compromised, then that's really dangerous. If the dikes, the control system of dikes are compromised, that can be causing the floods for us. So this risk for us, it's extreme. Then let's explore the options that we have. And I like to try to eliminate those options that we can't use them. So first, risk retention. It means that we don't do anything or apply Ostrich algorithm here or approach, but it's not possible because we know that it's extreme. Then we should immediately respond to that. The avoidance. In some countries, they do that, like North Korea or China, but I don't think that is possible anywhere else. So it's out of option. Then we have risk modification and risk sharing, these two options. Then I just wanted to revisit the definition of the security recently, that again, I got it from the ISO 27000, but the latest version, which is 2008, you can see that it's much longer text. They had 3 versions revised, but this definition is too long for me, but I wanted to highlight some part of it. That, for example, in this version, they tried to relate it to the context and to the context of the business success and continuity. So it's not related to nowhere. And then you can see that they talk about process, and then organizational structure. I like to translate it to the people. And they talked about software and hardware, which I translated to the technology. And then seamlessly integrated with organizational business process. I am, if you have experience of the traditional way of this the security departments were working, you know that why they tried to bring it to the picture, because they were totally separated islands. They were isolated. They were inside their departments, that they were different parts of the organization. So they thought that, okay, it's not working, let's change it. And then okay, they had the problem that, okay, we have this we can't make the system secure enough, then we should fix it. And then they tried to look into the similar context and then find the solutions that they were working. That's what we are doing in the academic as well, that we try to find an algorithm which is working in the similar context and then try to apply it to our problem. So they studied the DevOps. And then the DevOps problem the problem that it solved was the traditional way of working. We had the wall of confusion. It was the fight between developers and operations. Developers were incentivized by faster delivery of the features and fixes. So they wanted to deliver it faster to the production, and then they prepared the code, the package, and then they threw it to the operation. And then the other side of the wall, the operation was incentivized by stability, and the change is of course a risk for stability. And that's why they were protecting, and they were trying to avoid more changes. And that's why we had this issue. And then DevOps came up with more collaboration between these developers and operation, and it worked well. There is a book called Accelerate. If you haven't read that, I really recommend to do that. And they found that the companies that they are practicing DevOps, they have faster or higher velocity. But there is a misconception here that some people think that, okay, the DevOps was introduced because they wanted to improve the velocity, which is not true. The DevOps suggests to have faster experimentation, and then you want to have faster experimentation to improve quality, because if you do faster rounds and then you fail faster, then you can improve the quality of your deliverables. And the driver behind was, of course, the poor quality softwares or the systems. And that's interesting to know that in 2018, in US only, the cost of poor quality software was estimated to be about $3 trillion. So that's why it was introduced. And you can see the findings of the DORA project, that those elite performers, they have improved a lot in terms of the quality and the velocity. So okay, so the thing is, they said that, okay, let's try this DevOps way of working in the security field. And that's some misconception also that I have read here and there, that the DevSecOps was introduced because they wanted to secure DevOps. That's totally wrong. So they tried to use DevOps or DevSecOps because they wanted to make to use it in the security field. So how we can successfully implement it? First of all, we should consider that a chain is only as strong as its weakest link. Secondly, people, process, and technology are 3 pillars. I think we have highlighted it several times. Don't jump to the technology and accept that there is no end state. And finally, start measuring and stop measurement. Yeah, these are my opinions and my principles that I suggest. So let's go for the first part. I think you have seen some pictures like this, that sometimes you're obsessed about security of one part of the system, and then you spend a lot of effort, but you miss the other parts. So for example, if you have the highest, the most sophisticated firewalls, and then the most sophisticated mechanism and physical security, but your employees are not well educated and they give their passwords to the strangers, then okay, your system can be compromised. Or if you have IoT devices that they are not well configured, although that you have all your security measures, then okay, you can be compromised. The other thing is, I just wanted to highlight here that people, process, and technology, and I have seen that in some organizations, they are focusing on one part of this pillar and they don't have the balance. So that's not the way to go forward. And of course, I want to highlight that technology is enabler. Technology is not the solution. So like, I think Azqa also mentioned that ML is not a silver bullet. So you can't rely on one part, or the process itself cannot fix your problems. But don't jump to the technology. That's really important. I have seen that in many cases that they go to one conference that's okay, the IBM suggests to use this technology or this solution, then okay, we will be safe. Let's do that. That's dangerous because the technology can dictate your approach, but it's not the way to go. You should think of what is your scope, what is your context. That's something that you should be aware of. And then based on your requirements, even the level of your human being, you should decide of which technology is more suitable for you rather than the other way around. So accept that there is no end state. Heraclitus says that the only constant in life is change, so the change is inevitable. And the way that in traditional way of the security we were working, we had the starting point of the project from point A to point B, and then when it was delivered to the production, then the security team were doing some security scanning, server hardening, and penetration test. Okay, it was successful. Yeah, cool. Then it's done, and they forgot everything about that. But it's in real life, we know that it's not the way to go, because if you do, for example, the COVID-19 test, and then you need to wait for 1 day to get the results. But when the result comes and says that it's negative, it doesn't mean that you're not affected. Maybe you have been infected just after you got the test. So you need to do it iteratively and then try to make the test cheaper and easier and faster so that you can do more frequent. Yeah, the importance of the measurement, that's really important. And you should know that what you want to measure and what not to measure. And understanding of the metrics, it's really important. I'm happy that Azqa also touched upon that to understand the metrics. So some practical approaches. First of all, again, I think I am known as a people-centric person, and that's why probably I'm focusing on the people. So start from the people. That's my suggestion. And I have seen that people are making lots of stupid mistakes if they are not well educated. And then try to build risk-aware culture. If the people are aware of the risk, they will make better decisions. So try to focus on people mastery. You know, and I want to just give you an example about this focusing on the people. Many years ago, I was a team lead, and I was a lead of the release of a change to a banking project back in Malaysia. It was really tough situation, and the directors of the bank, they were shouting on each other for some issues. And at that moment, I realized that the security officer information security officer who was in charge of hardening of the servers, he was smiling. So I went to him and I realized that he's playing a game, a Facebook game. And I was surprised because I knew that Facebook was banned in their network. Then I asked him that, okay, Facebook is banned in your network, right? And he said, yes, I did it myself. Then I asked him how you are playing that game. And he said, you know, I'm doing the VPN to the server. And because in the server, it's open to everything, then I can play this game there. And I said, oh, that's really cool. That's really cool. So you know that when you are opening the VPN, everyone else also can do that to that server, right? And okay, so he wasn't aware of the risk that he's making to the entire system. But if you teach them that, okay, what's the danger, then they can make the better decisions. And then try to measure the team level skills. You need to have different skills, and then try to focus on DevOps capabilities. There are some capabilities came up from the DORA research again, 24 capabilities. And then if you focus on those things, it covers what you need, at least what I believe. So again, I want to highlight the importance of the measurement, because without measurement, the DevSecOps is just a hype for you. It won't deliver any value for you. It is important to measure what it matters to you. You know, sometimes I have seen that people are measuring something and they have some beautiful dashboards that they have those charts that it shows to them, but then I am asking, okay, what you gain from these charts, what it shows you. They don't know that because, okay, it's beautiful, but sometimes it's also the problem is because they have the technology and that solution delivers some telemetry, then they are using that because it's easy, but they don't know what they are using. That's dangerous. And it also it has a danger of false sense of security, which you don't want to be in that situation. Don't build wall of confusion again. Please, okay, I have seen in some cases that they have the dashboard and measurements for the entire team that they are monitoring, and they have a special dashboard for the security team. So they are measuring the security incidents and the bugs and whatever. Then it means that, okay, the security team is responsible for those issues, the bugs, and the other bugs are responsibility of the other team member. So you are not saying that, but the wall of confusion is going up. Please don't do that. All the bugs should be considered as bug, either is security or not security, but you should have some risk management and then identify the level of that bug. So, and not measuring of anything is better than measuring bad KPIs. That's something that I really say that, okay, if you, because measuring of the bad KPI will make the poisonous culture in your environment. So that's really dangerous. And sometimes I'm referring to the measurement or telemetry collection as a sample of you have some sensors, and then you can use those sensors to collect some information for you. But you should know that why you are using those and what you want to gain from it. So if you want to, for example, you have the moisture sensor, but you collect all those information, but what you will gain from it. That's the question that we should ask. So implement the zero bug policy. I think it's for the entire team. That that's some kind of risk management again, that you do the risk analysis of the bugs and then treat them based on the level of the risk that it exposes to your team. Measure and learn from it. The purpose of the measurement should be learning from it. Then it's kind of collecting the measurements and then we learn from this to improve. False positive alarms are dangerous. In real life, we have experienced it as like, for example, if you have a buggy sensor that sometimes out of the blue, it just alerts, then after a while, you will reduce your sensitivity against that, and it's dangerous. So in my ex-company, for example, a third-party company, they implemented a kind of alert system that after 3 times that I received false negative alerts, I pushed and asked them to just remove it and then fix it until that time. I didn't use it because it was reducing my team's sensitivity. They were ignoring those alerts. So something else here that I like to highlight is shift left to push quality upstream. So the way that we were using the quality assurance, especially in the security, was towards the end of the project. So we implemented everything, and then we wanted to deploy to the production. In some cases, we had the server hardening, and then we realized that, oh wait, after this server hardening, the system is not working. Then we need to fix it. And how many times you have experienced to fix a bug and then you introduce few bugs? I think all of us, we have experienced that. And it's too late to do that. Then sometimes people said, oh, we have to deliver, and then let's close our eyes, or let's not report this bug because otherwise we will be questioned. So let's try to find those bugs as early as possible. And then design for testability. If you have two alternative approach, one is both are equally good enough, but one is more testable. Go for that part, because more testing is your friend. Then use infrastructure as code and policy as code. The reason for it is, when you are going for infrastructure as code and policy as code, or everything as code, it improves the testability and makes peer review possible for it, and automation also will be available. And another good thing is, if you do that, then you can have this code and pass it to the model that Azqa trained, and then it can be automated and it will be fixed the bugs if you have it there. And then, of course, earlier bug detection, you can have higher quality. Another thing is, beside the shift left, I think what we should do here is shift right and to test in production. Although that it sounds scary, which is scary, but we should do that. Otherwise, we won't be able to make our environments secure and safer for us. The test in production is it's like testing the business continuity and disaster recovery plans. That's something that we should do it. And it's really important to practice it. Otherwise, when the situation happens, the disaster happens, you won't be feeling comfortable to implement those disaster recovery. I have been in that situation that I asked the operations or the people in charge to, hey, initiate that disaster recovery because the system is down. And then they was, no, I don't dare to do that. But then, okay, when you want to do that, it's like, that's the situation. But because they haven't practiced, then they are not feeling comfortable. It happened in the Chernobyl as well. Then they knew that they have to initiate that process, but because they haven't been trained, they haven't been practiced, they couldn't do that. So test detection and response control. We have the detection and response control in our environment, but if we don't test it, we won't be able to realize that whether it's working fine if that compromise happens in our environment. So we should do that in production and test it in production to validate the hypotheses, because there is no better environment than production, right? And test and acceptance might not be might not be able to simulate the exact environment of the production. And then test the telemetry collection and measurement mechanism is working. You might have the alerting system and telemetry collection, and I have seen that in some cases that the telemetry collection or alerting system, they weren't working for years, but nobody realized that because they haven't tested whether it's working. It's like you have the sensors installed, but you need to test it whether it's working. And if you don't, it might stop working and you haven't realized that. And then you had false sense of security that, okay, I don't have any alerts, but then it means that it's secure. No, it might be that your telemetry collection is not working. So you need to test people, process, and technology all together, like the fire drills. We do the fire drills to simulate the real situation, to test what people are well aware of what they should do in the case in that situation, whether the process is correct and it addresses the situations, and the technology that we are using is working. Another thing is harness the failure to continuously improve. Sometimes we are using the fault injection, but it should be in the controlled environment or chaos engineering to introduce some security compromises, and then we collect the information and then learn from those lessons and try to improve it. So it's kind of practicing and simulating the situations ourselves and making some data that we can reuse later. And another thing that I like to highlight is the do not underestimate the importance of the architecture for establishment of the context, setting scope, and aligning the people understanding. Because if you don't have the correct architecture in place, then you won't have the bigger picture in front of yourself, and that's easy to lose that picture, and then you might have this issue that I showed with that gate out of nowhere. And then understand the diagrams for all the stakeholders. It's really important to have those diagrams that understandable for people. You can come up with some diagrams that scare people, and that's not helping you, because if the people are not understanding the system, they won't be able to find the bugs and then address it. So you should have something like the blueprints of the houses that everyone can read. That in Funda you can see the the plans of the house, and then you can understand it. And of course, the experts and architects also, they can use it for their communication. And another thing is verify the architecture diagram. You might come up with some beautiful architecture diagram, and you can come up with some deployment diagrams or whatever, and it's really beautiful, and everyone says that, okay, that's working, we are safe. We apply all those principles in these diagrams. But then the question is, if you don't verify those architecture in the real system, it's useless. I have one example for you that a few years ago I was working in a bank back in Malaysia, and I went to the office Sunday morning because I had to work on a report for the Central Bank of Malaysia. And I saw some zombies working around, and some people were laying down. And then the CTO of the bank, Bill, was frustrated and sitting there. And then they found that, okay, there was a bug incident that they were working on to fix it from Friday until Sunday morning. And at the end, they realized that the implementation of the firewall and routers were not exactly as what it was in the architecture. So he asked the head of the architecture, enterprise architecture department, to have a policy and a process to verify the architectures. Design for failure, it says that, okay, we know that the system might fail, then we should have some detection and response mechanism in place. Make doing the right thing easier rather than making the wrong thing difficult. It's really important that you have this mindset, because it will save a lot of efforts for you. I have some examples that I can share with you later. So at the end, you can see a lot of buzzwords, like I have collected something like here, Devsecops, that I have seen it this week. It was really interesting for me. BizDevSecOps or DevSecOps or SecDevOps. And you can see something like DevSecBeerOps as well. But that's really interesting. I just want to go back to the findings of the DORA project and highlight this finding that says those elite performers, they have reported 50% less time fixing security issues. It means that they were more safe compared to the low performance companies. So my That's my opinion, by the way, that the sec in the sec DevOps is a noise. So when we were doing the deciphering, sec was a noise in that decipher in the ciphertext. And from my perspective, reinvention of different words like DevSecOps, MLOps, SecDevOps, or so on, are due to not enough knowledge and experience of DevOps, or just for fun, something like DevSec BROps. And with that, I'd like to thank you, and I'm here for any questions.
All right, unmute applause to the people who are left in here. So we had some people that had to leave. Thank you. Questions? I had a question. So let's indulge ourselves in a bit of a scenario, I guess. If you had a lot of servers to manage, what would be your tool of choice, for example, to efficiently ensure the security of develop or deployment for multiple systems? Is I guess what I'm asking. What's your choice?
Okay, you want to make sure that those servers are secure, right?
Yep.
Okay, so again, telemetry collection. So you want to know that, okay, in these servers, again, you should go back to the architecture diagram. So you have the architecture diagram says that this server should be able to communicate to this server and on this port, and that's it. So you know that you should close all the other ports. Then when you are using the infrastructure as code, then you implement it, whether it's you are using the Terraform or CloudFormation or ARM templates, then you develop it as it's expected, and then you have the telemetry collections of the request going to that server and coming back, or the responses. So if you have those metrics, and then you define that, okay, if there is any request coming to something else which is not blocked, then except that port X, for example, then send an alarm to me. Then in this way, you can be aware of something is going wrong. But of course, you can have some mechanisms in the, for example, for pull request reviewed, you want to ensure that the test it against the policy that you have, and then it will be automatically blocked. So you won't have those changes into production beforehand.
Thank you. Thank you. Anyone else? Feel free to just unmute if you have any questions.
I have a question about how can we make it so that taking care of security is not a hindrance to the development team. How do we integrate it nicely into development process?
Yeah, okay. I think something that also in DASA, it is highlighted that we should have some kind of knowledge for entire team about security. So, for example, the development team, they should be aware of the OWASP top 10, for example. They should have some, they should be taught about the security risk, and then they should work with the security officers closely. Of course, they can't be as expert as an experience as the security officers, because their focus is in that area. So we should have some generalists that they are expert in development, but they are aware of the consequences of their decisions. And when they are working together, by the way, they can bring their knowledge of each other higher.
Right, thanks. But can we integrate it somehow into the development process? So I'm not sure, maybe some tools that could check our code automatically to notify us of issues.
Yeah, we have different tools that supports us in different life cycle. For example, when you are developing your code and then you want to commit, then you can do some pipeline. You can do some validation pipelines that they are it's testing and running the unit test. So you can write some unit tests for specifically for testing the security concerns that you have. And then if it fails, then you are aware that okay. There are some breaches in the code, and then I have to fix it before it's merged to the master. And also we have some static code analysis tools that they are checking against those vulnerabilities in the code. And even when it goes to the test environment or acceptance environment, you have some tools that they are testing against latest vulnerabilities and exploits. Yeah.
All right, thanks.
Okay, anyone else? All right. Thank you, guys. Thanks a lot for the talk, Jafar.
Thank you.
Super informative, very detailed. And thanks to anyone who's still here. You're the real ones that stuck around. I wanted to propose a group picture, but there's not many people left, so it's probably not worth it. Next time we'll have to do it at the beginning, as we did last time. But with that being said, I hope everyone has a good rest of their day. The recording for this will be available on YouTube, and you can find a link to that either on our Discord.